Hi, ladies and gentlemen, this is lesson 1-2 HW1, manipulating equations, and some additional notes. We're going to go over our first couple little problems here in the homework, and then you'll finish off the rest there. So your objective, you'll be able to find the area of a donut. That's a very informal objective. It's really that you're finding the area of overlapping figures or the shaded region, but the donut kind of gives us a good idea of what we're going to be getting into. We're going to find the area of a circle, excluding a piece of that circle. And you'll see a little bit more in detail of what we're talking about in the next upcoming slides. First off, as you probably already know, this is a circle. It's fully round. You know, this is inside the circle, and you know this is the outside of the circle. And the circle, the rim, is called the circumference of the circle. And we're also going to be talking about the area of inside this circle. So inside, all the area inside the circle is called the area. Now we can find the area of a circle by this formula here of pi r squared is equal to the area. So I'm going to give you the radius, and you can plug that number into the radius, you square it, and then multiply it by pi, and that'll get you the area. Or I like to just say, if I give you a radius of 4 squared is 16, I would say 16 pi, because that's just a little bit easier and a little bit prettier when we write things out. So the area will be 16 pi. Let's do a couple examples. Find the area of a circle. That's our formula. If the radius is 4, well, that's what we just talked about. We did 4 squared. That will get us 16 pi. I'll zoom out a little bit. 4 squared, and that will get you 16 pi. All right. Let's try another one. Find the area of this red circle. So area is equal to pi r squared. If my radius is 7, the area will be 7 squared pi. 7 squared is 49. So the area of this red circle is 49 pi when our radius is 7. The next one will be find the area of the blue circle when the radius is 11. Well, we put 11 in for r. It will be 11 squared times pi, which is 121 pi. So that's how you find the area of that circle. This dark blue circle, if the radius is 13, like 13 feet, it would be feet. So it'd be 13 squared pi, so it'd be 169 pi. And if it was 13 feet, the radius, it would be the area would be 169 pi square feet. Or feet squared. Next is a circle. It kind of looks like a donut to me, similar to this picture of a donut. We have the outside of the donut, like the outside of a circle, and the inside of our donut circle is empty. And that's what I'm representing over here. The inside of the circle is empty. We'll slide them up. So you see it's a full round circle. Our goal is to find the area of this pink shaded region. That's going to be our goal for these upcoming slides. So to do that, we first find the area of the big circle. The big entire circle, meaning without that, we're finding that area of the pink circle. Then we're going to subtract the area of this little circle. And now it gets the area of this pink. So once again, we find the area of this pink circle, the big pink circle, and then we're going to subtract the area of the little circle, the white little circle. And that's how we're going to get the area of this pink, the outer donut here. So let's do it together. We're going to do the area of the big circle minus the area of the little circle. So I'm going to delete that. Let's do this step by step. Let's say the radius of the big circle is 10 feet, and the radius of the small circle is 4 feet. Our goal is to find the area of the pink donut. So what we would do, we will first find the area, given the 10 feet. And how we do that, when we do area is equal to 10 squared pi, which will be 100 pi. I'm going to abbreviate, so 100 pi. And the radius of the small little circle is 4 feet. So the area, 4 squared is 16, so we get 16 pi. So our answer of the donut, the area of donut, is equal to 100 minus 16, or 100 pi minus 16 pi, which will get you 84 pi. So the area of this pink area is 84 pi. Let's do one more together of this style. We can remember do the area of the big circle minus the area of the small circle. So let's say the radius of the big circle is 15 feet and the radius of the small circle is 8 feet. We're going to find the area of the pink donut. So the radius being 15 feet, the area then will be 15 times 15. 15 times 15 is 225. So 225 pi, because it's 15 squared times pi. And the area of the small circle is 8 feet. 8 times 8 is 64. So A equals 64 pi. 225 minus 64 pi. Well, 225 minus 64, we could use our calculator and we could find that out. Let mine load. So 225 minus 64. 225 minus 64. That will get me 161. So this area is equal to 161 pi. So 161 pi. And I believe we're talking about feet, so it would be feet squared. So 161 pi feet squared. Number 3 you could do on your own, 4 you could do on your own, 5 you could do on your own. Now we're going to step it up a little bit. We're going to apply this concept to park material. So here's problem number 6. This is what it looks like on the park. I believe this is the practice problem that they provide. Part A, which of the functions for the area A that is inside the larger circle but outside the smaller circle with the smaller radius of R? So our goal is to figure out which one of these functions could represent us finding the area of this shaded region of the donut. So we already know, like we've been practicing, the area of the large circle minus the area of the small circle. So if the area of the large circle, based on this information, is 14 squared pi, we're going to do 14 squared pi minus pi r squared. Now what is 14 squared? Well, we're going to crunch out that number and we're going to get 196. So I'll bring this information up a little bit. So we know the area of the large is this, the area of the small is that. So let's delete that. We'll slide up this. Oh. There we go. Make it a little bit prettier. So it's going to be 14 squared minus pi r squared, because remember we're doing the area of the big minus the area of the little. 196. So it'll be pi times 196 minus pi times r squared. Then we're going to factor out a pi. We're going to pull out a pi because we don't need to repeat the pi twice. We can factor things out, so all we have to do is write it once. So it's going to be pi times 196 minus r squared. And that will be our answer. So all we did was just big minus little, and then we did a little bit of factoring. Now a little bit of factoring is a little bit on the old stuff because it's been a while since we did factoring in class. But you just pull out what they have in common and you put that on the outside. So the correct answer would be C for this problem. Let's do another one of these. Number 7. The diagram shows two circles with the same center. A large circle has a radius of 12 feet and a smaller circle has a radius of r feet. Write a function for the area A that is inside the larger circle but outside the smaller circle with the smaller radius of being r. So these are the same directions, just like the park presentation. I said that it's 12 feet is the big guy. So I'm going to put 12 feet in for r for the radius of the large circle. And a small circle is just a formula. Area equals pi times radius squared. Large minus small. So I put it in that little format going left to right. Large minus small. I take away the a equals from both sides. Then you're going to see there's a pi in front. 12 squared is 144. We're then going to factor out the pi. So pi times 144 minus r squared is our answer. So we successfully written an equation to find the area of that shaded donut. So we wrote an equation given that the big donut has a radius of 12. And we don't know the little radius of the little circle on the inside. So we're just leaving it as r. That's problem number 7. Let's try problem number 8. We have a radius of 20 feet. And the radius of the small circle is r. So we're just going to set up our equation. So the area of the large circle is 20 squared pi. And the area of the smaller circle is just pi r squared. Because we don't know what the radius of r is for the small circle. So I plug it in, make it write it out horizontally. 20 squared, we take out both the a equals. 20 squared is 400. Now we have 2 pi's here, and we just factor out the pi. So it'd be pi times parentheses 400 minus r squared. Number 9 you could do on your own. 10 you could do on your own. 11 you could do on your own. 12. Next step. Now you could apply this concept to various figures like rectangles and triangles and any other polygons you could think of once you know how to find the formula for each one of these polygons. And it's something we could practice and try also in class. So if we have a square, we could apply that too. We could find out what the area of a square is, which is length times width. And we're going to do the area of the large rectangle, 8 times 5 in this particular problem, minus the area of the small rectangle, 2 times w. And we could work on factoring things out and manipulating the formula. It's just big minus little to find out this blue section here. The blue looks like almost like a picture frame, similar to a donut. Find that blue area. So we find the area of the big blue box. We subtract the area of the red box. And that will get us the area of this blue picture frame. 5 times 8 is 40. And the area of the small is 2 times w. 40 minus 2w. And we can factor things out. We can factor out a 2 because 2 is divisible by 40. Or 40 is divisible by 2 and 2 is divisible by 2. And that's how we get an answer for number 13. Oops, I meant to do that. That's the answer right there. Just so you could see. Yeah, the 40 is divisible by 2, so you factor that out. 2 is divisible by 2. So you get a little 1 minus 1w. Or just regular old minus w. And you could do 14 on your own. And that's it, ladies and gentlemen. So why'd you try finishing up the rest of those problems? If you have any questions, please ask during class or come to Extra Help. I'd be happy to help you out in Extra Help with some of this park material. All right, have yourself a wonderful night.